Welcome to a lesson on the deduction rules of Modus Ponens and Modus Tollens. A valid argument is a list of premises from which the conclusion follows. How do we know the following argument is valid? If John earns $300, then he will buy a new phone. John earns $300, therefore, John will buy a new phone. Let's look at the form of the statements. Let P denote John earns $300 and Q denote John will buy a new phone. The logical form of the argument is if P then Q, P therefore Q. This is an example of a deduction rule, an argument form which is always valid. This one is a famous rule called Modus Ponens. To show this deduction rule is always valid, consider the truth table to the right. Notice that all the lines in the deduction rule have their own column in the table. We have a column for P, a column for Q, a column for if P then Q, and we also list the columns of P and Q again. These last two columns are optional, but it is nice because notice the last three columns are in the same order of the argument. We have if P then Q, P, therefore Q. An argument is valid provided the conclusion must be true given the premises are true. The premises in this case are if P then Q and P. Which rows of the truth table correspond to these being true? Notice if P, then Q, and P are both true only in row 1. P is true in the first two rows, and of those, only the first row has if P, then Q true as well. And thus, in this case, notice Q, the conclusion, is true as well. When all premises are true, the conclusion is true, therefore we have a valid deduction rule. And now let's consider modus tollens. Consider the following argument. If you have a current password, then you can log on to the network. You can't log on to the network, therefore you don't have a current password. If we let P denote you have a current password and Q denote you can log on to the network, the logical form of the argument is if P then Q, not Q, therefore not P. This is another example of a deduction rule, again an argument form which is always true. This one in particular is the famous rule called Modus Tollens. To show this deduction rule is always valid, again consider the truth table to the right. We have a column for P, a column for Q, a column for if P then Q, a column for not Q, and a column for not P. Again, notice how the last three columns are in the same order of the argument. We have if P then Q, not Q, and not P. And again, remember, an argument is valid provided the conclusion must be true given that the premises are true. The premises in this case are if P, then Q, and not Q. Notice if P, then Q, and not Q are both true only in the fourth row, and in this fourth row, the conclusion of not P is also true. Or more specifically, not Q is true in the second and fourth rows, and of those, only the fourth row has if P, then Q, true as well. Thus, in this one case, again, when both premises are true, not P, the conclusion is true as well, which indicates we have a valid deduction rule, again, because the conclusion is true when all premises are true. I hope you found this helpful.